Alright, hey guys, this is Team Awesome here, and I'm going to show you a little bit about fluid flow analysis in SolidWorks. So starting us off, you need to make sure you have the flow simulation add-in active, and so then you can have this little tab over here. And I've already started a little bit, so I'll just show you how I got to this point. You're going to go up to the wizard to create a new test, so I'll just do that, I guess. You can name it whatever you like, add whatever comments you want. Here the key is you can pick your individual unit set. I went with IPS just because that's what I have everything built in. I'm analyzing an open plate, so I need to select an external analysis type. If you're analyzing flow inside of something, you would have to pick internal. And then the rest of these I'm not really going to play around with. Here I'm going to pick my fluids. You can do liquids, gases, whatever I like. Water should be interesting. And I want to keep the flow type fully defined here, so I want laminar and turbulent flow together, but you can pick one or the other if my mouse would stop double clicking. And pressures, we're not really playing around with super high pressures, so cavitation is not really an issue. And then this is the last page of this where I'm going to define my initial and ambient conditions. Right now I have standard temperature and pressure defined. And here's the important piece. To analyze an actual flow, I need to give it a flow direction. So right now I have my Z direction, as you can see on the little model, is going to be down the plate. So I want to change the actual Z velocity to, I don't know, let's use 12 inches a second. And then that's going to be represented by this little vector sitting here on my origin. So if I add in an additional direction, say 3, you'll notice the vector changes. So you can get a real representation of which direction your flow is going, just for a little sanity check. So go ahead and finish that. And it's going to bring me out to this screen, which is going to be defining my computational domain where the solver is actually going to solve. So I want to go in here and change that. You can either do it on the numerical scale, or you can just drag and drop these arrows if you're just doing sort of a general look. That's what I'm doing. So I'm just going to drag these arrows in. I want my bottom to start at the top of the plate. I'm not looking at the flow underneath the plate, I'm just looking over it. And minimizing your computational domain will also decrease the amount of time it's going to take to solve it, because it's solving over a smaller area. So once you have that defined, you go ahead and press the check mark there, finalize that, and the only other thing you need is to define some goals. So under the Goals tab for global goals, you have a plethora of options. I just care about the average velocity. So I'm going to make that check mark, and this will also have a huge bearing on how long it's going to take to solve. So once you have your goals defined, and it will show them right here, the mesh is going to be automatically generated, so you don't really need to play around with that. And then that should be everything you need to run a test. So once you have that set up, you can go up here and hit run, and it will run through the actual solving of your situation. And I've already run that on a different one of these, and I've already got some plots made up that I can show you real quick. So this is a different plate that I've done, same solving for average velocity, and I've created a few plots. So under a cut plot here, this is going to be basically generating a plane that you're going to look at, just a slice out of the whole system. So right now I wanted to select the front plane, but you can clear that and select whatever you want, faces, planes, whatever, and then you can drag and drop or calculate where you want that plane to intersect things. And you can select contours, so that's just going to provide a color map of the values, the range of values. Streamlines will do the same thing, but with lines. Vectors will show you the actual direction that it's demonstrating, not just the magnitude. And then just want to make sure down here that you have the correct option selected, and then you can change the number of levels. So a higher number will give you a smoother, more chromatic graph. So once you do that, you can hit OK. I've already got one made up that I'll just show you. And then you can drag and drop the scale bar there. And this is going to show you the flow magnitude and flow direction out of these guys. And the arrows will get tighter. You can actually define the spacing of these arrows and the size graphically in the cut plot wizard. And then on here we can see the velocity chosen. I have a different one here. Let's see which one this is. This one is measuring both velocity and vorticity. So I have the contour showing vorticity and the streamline showing velocity. So these streamlines are showing the magnitude of the velocity. Darker is slower, red is faster, and then the underlying background color is going to show you the actual vorticity. So it's more vorticitous in the darker regions than in the slightly lighter regions out here, which is going to basically show you the it's going to show you the eddies and all those sorts of things. This was another interesting one. Surface plots allow you to show a whole bunch of different things on surfaces. So here in fluids, if you select a velocity surface plot, you're not going to get a very interesting thing because it solves with a no slip condition. So the velocity will just be zero everywhere. But here I've picked pressure, so the flow is coming in from this direction, and you can see on the very leading edges of these surfaces, pressure is a little bit higher. As you can see, the scale is almost negligible. But if you were doing sort of higher velocity flows, you could get a much better picture. Isosurfaces allows you to do much the same thing, except for here I've chosen the pressure. Again, the range is very small, but this shows you the range, the areas where these conditions are met. So as you can see, the pressure is much lower over here than it is up here, just by the color that I've chosen on there. And all of these wizards have the same interface. So you just pick your average values that you want to look at, parameter, velocity, whatever. This actually should be pressure. And then the last one that I think is the most visually interesting is going to be a flow trajectory plot. So I went through and I selected all these edges that you see highlighted. And it's going to show me the magnitude and direction of the flow vectors, these velocity vectors I have. And another really cool thing with this feature is it's an animation. So you can hit play under that option, and it will actually show you the flow moving through, and you can see how these different streamlines are changing direction. So by looking at this and seeing where the most sort of action is going on in terms of rotation, you can see where those vortices are going to generate as well. And also the actual flow velocity of the arrows is related back to the actual flow velocity of the flow. So those are just a few interesting features and entertaining features sometimes with some cool plots of flow simulation in SolidWorks. I haven't explored all of these quite yet, but they are very powerful for analyzing a multitude of different situations and bodies. And you can also do internal flows as well. So if we drew up a nozzle, we would just have to change that initial input data to an internal flow, and we can see much the same data as we did out here. So thanks, guys. Have a good one.